Hi everyone, I'm Yusuf Korkmaz. I'm a freshman of the Department of Electronical and Electronics Engineering in Bilkent University. In this video, I'll be explaining my Physics 101 project, and it is about the effect of the coefficient of friction on the energy loss. My setup in this experiment consists of an object, a string, a ruler, and most importantly, three different inclined planes. The experiment is comprised of three parts involving three inclined planes, different from each other. Firstly, I set up the inclined plane with the spring at the bottom of the plane, and with the angle that will stay the same through every plane. Then I compressed the object about 3 cm, which will be written down as 0.03 meter, and released it. I pointed out where the object stops to measure the distance traveled and tried it down. I've done the same things for the other inclined planes. Using the compression and the spring constant I used through my experiment, I calculated the spring potential energy. Then, using the distance traveled and the angle, I calculated the height the object reached, which then I used it for calculating the gravitational potential energy. I found the differences in the initial and final energies, which correspond to the energy loss due to friction. I then used that energy to find the coefficient of friction by the fact that the work done by friction should be distance traveled times friction force. I observed that when the coefficient of friction gets bigger, the energy loss also gets bigger, as intuitively predicted can be seen in the graph. I also knew from the theoretical parts that the energy loss with respect to the coefficient of friction should correspond to a hyperbola. Even though the experimental data did not perfectly execute that, I've been aware that there will be some errors in my experiment since there is no ideal plane or spring. These outside effects that cause some errors are basically the air resistance, the rough and uneven planes that are far from ideal, the spring that has different potential energy every time it's compressed since it is not ideal also, the change on the gravitational acceleration due to displacement and not being 9.8 everywhere, this strange I put in the object that differs every time I try it, and some measurement mistakes due to the ruler. Though the error percentages got lower through the x-axis. When the coefficient of friction is 0.26, the error is 52.8%. When the coefficient of friction is 0.34, the error is 42.4%. When the coefficient of friction is 0.65, the error is 23.9%, as can be seen in the graph. It can basically be explained by which the more distance the object traveled is short, the less the object encounters non-ideal factors, especially the air resistance, which is the biggest obstacle through idealization. Thanks for watching.